In this video, we'll try to understand what is reflection in C#, how to implement reflection, and why do we need reflection. So let us first try to define reflection. Reflection helps you to inspect content of an assembly. Content means, metadata of an assembly, like, what are the methods in that assembly, what are properties in that assembly, are they public, are they private, etc. For example, one of the biggest implementation of reflection is in your Visual Studio itself. In your Visual Studio, when you go and create any object, when you go and write a code, to create an object, for example, you can see on your screen, I'm creating an object called as X, which is of type string. And when I say X dot, what it does is it actually uses IntelliSense and it displays all the methods, properties or functions, for that class, right? And also, it displays, if they are public or private or whatever it is. And this is possible because of reflection. So reflection actually goes in, it inspects your assembly, and it displays the metadata of your assembly. So now that we have got the definition of reflection, the next thing is, let's try to implement a simple code of reflection. Okay. So what I'll do is, let me go to my project here and let me go and add a class library. So let me go and add a new project here, and I'll go and add a class library saying some class library. Okay. And in this class library, let me go and add some public and private methods. So I'll just go and add here one public method called as method 1 and a private method called as method 2. Let me also go and add some properties here, variables here. So like public int X, right? So I've created a very simple class here called as class 1, which has a variable X, method 1 which is public, and method 2 which is private. And let me go and build this. So once we have built this class library, it will create a DLL of it, right? So if you go and browse the folder, the bin directory, you can see that there is this DLL saying some class library.dll, right? Now what I would like to do is, let me go and copy this address. I will go and remove this class library first from the project, right? So in this folder now, I have created the DLL. Okay. Now what I would like to do is, I would like to go and use reflection, and I would like to go and browse the properties, methods of that DLL, right? So in other words, from this console application, I would like to use reflection, and I would like to go to this folder, to this DLL, and I would like to go and display, what are the methods, what are the variables in that class, right? And that is possible by using reflection. So let's see a demo of it. So implementing reflection is a 3-step process. First is, you need to import the reflection namespace. This is nothing but using system.reflection, right? The second thing is, the second step is, you need to go and get the type of the object. And once you've got the type of the object, you can go and then browse metadata of that object. Metadata means properties, methods, whatever it is. Okay. So the first step is, you will go and import the namespace, which I've already done. And the second step is, you will go and get the type of the object, and then on the type, you can go and browse the metadata. Now in order to get the type of the object, the first thing what you have to do is, you have to get the reference of the assembly. So in order to get the reference of the assembly, we have to use assembly.load file, and then we need to give the DLL path, where exactly the DLL is located. Once you have got the reference of the assembly, the next step is to go and get the class reference. So class reference means, over here you can see, once I have got this my assembly object, from this DLL, I am saying that in that my assembly, can you please go and get me the class 1 type? And once I have got the type of the object, then I can use that type of the object to go and create an instance of that object. And for that, we have to use activator.createInstance. Why activator.createInstance? Because this DLL is not referenced currently into my console application. It is referenced via this reflection, right? And once I have created the object, the other things are very easy, because we can use our get type method to get the type of the object. So now that we have received the type object, the next thing what we can do is we can go and browse members. So you can use get members function here. If you want to go and browse methods, you can use get methods function here, right? So let's say we want to go and browse all the methods and variables inside this class. So for that we can say for each member info in dot get members. Okay, if I want to draw what you call browse all properties, I can say get properties, get methods, other things I can use. But currently I want to just go and browse all the members which are exposed via this class, right? So if I do a control F5 here, you can now see that he has extracted all the methods as well as the variables. So you can see method 1 which we are declared in our class, that has been seen here. You can see the X variable, that has been seen here. Also you can see there are other methods which actually belong to the .NET framework, like toStrings, equals, etc. Right. So that was a simple demonstration of how to use reflection to go and extract metadata from a class. So let me talk about some more good features of reflection. One is basically it goes and it inspects metadata of a class, right? The other good thing about reflection is, one, it has inspected the metadata, it can go and invoke the members, or it can go and set the values to those variables if you want it. So for example, in our class here, right, let me just go and add our class library again back. Let's say in this class library, let's say by using reflection I want to go and invoke this method 1. Okay, so what I'll do here, I'll just go and write a simple console.write line here so that we can know that this method was invoked, saying that this is method 1, right? And let me build this. Let me go and remove this class library just to ensure that it is never referenced in the console application. Please note, this class library is not in the references of our solution project, of our console application project. It is using reflection to do whatever operations we are doing now, right? So now what we have done is in the method 1 we have put a simple console.write line. So now by using reflection we would like to invoke that method 1. Now in order to invoke method 1 we need to use the invoke member method or invoke member function of the parameter object. So you can see that I'm saying invoke member, and then I'm saying method 1, and then I'm passing various binding flags here which indicate that this is a public method, it's basically tied up to an instance, and also I'm passing the object instance wherein the method 1 will be invoked. Now remember that this invocation is happening completely on runtime. In other words, reflection does not know that if method 1 actually exists, right? So he just tries to invoke it. In case it does not exist, it will throw up an error. So complete dynamic invocation. This process what you're seeing now is a complete dynamic invocation, a runtime invocation, right? So if I do a control F5 here now, you can see that he has invoked the method. You can see this display here. This is method 1, which is actually coming from that method 1 call. So let's summarize. There are two big benefits of using reflection. One is it helps you to go and inspect metadata of a class. Second is it can go one step further. It can go and invoke the invoke members of a class completely on runtime. Now before I end this video, let me quickly talk about some practical uses of reflection. Now there are unlimited use of reflection, but let me talk about some 2 or 3 over here. First one, which is definitely you will use reflection, is in case you are creating IDE softwares like Visual Studio, where as you type dot, you would like to show all the properties and methods of that class. Second is in unit testing, many times you probably would like to invoke private methods. Okay, now that's a different thing. It's a controversial topic that you should invoke a private member or a method in unit testing or not. But many times while you do unit testing, sometimes you need to invoke private methods for various reasons. Okay, so at that time also I find reflection very useful, because there is no other way of invoking private members on object instance from unit testing frameworks. Third is sometimes we would like to just go and dump properties and methods and references of a assembly or of a DLL, to a file, or probably you would like to just show it on a screen. At that time, again, I find reflection to be very useful. So these are, some of the practical uses of reflection. Again, as I said, there are unlimited use of reflection, because once you say that you can inspect a metadata of a DLL, then only the sky is the limit, right? Now, there is one more keyword, which does similar things what reflection does, and that is the dynamic keyword. Now, as I said, that in reflection, we can inspect metadata as well as you can invoke methods or functions of a class or an object dynamically on runtime, right? Even the dynamic object, which was introduced in 4.0 does the same thing. So there is a lot of confusion, between developers, what is the difference between dynamic and reflection. So in the next video, we'll talk about what exactly is this dynamic keyword which was introduced in 4.0 and what is the difference between dynamic and reflection. So I'll end this video of reflection over here, and in the next video we'll continue talking about dynamic and dynamic versus reflection. So I hope that you enjoyed this video. In this video we talked about reflection, we talked about where reflection can be implemented, and we also saw a simple code of how to actually implement reflection. Thank you so much.